Okay, thank you very much. Thank you very much. My name is Getahun Sisay. I am a PhD student at the University of Gondar. Here I am undertaking my PhD mobility under the Erasmus program. Now I am going to present my work, which is one of the specific objectives of my PhD dissertation. Actually, I have 5 specific objectives for my PhD dissertation, and today I am going to present one specific objective of my PhD dissertation. Okay. I'm going to present my work on quantifying carbon sequestration and habitat quality ecosystem services in Northwest Ethiopia. As you know, natural ecosystems provide different ecosystem services and functions, especially forests sequester large amounts of carbon dioxide, and they play an important role in climate change mitigation. Similarly, grasslands, wetlands, and shrublands provide us different ecosystem services like biodiversity support, regulating services, and many more ecosystem services and functions. Especially the tropical forests support different biodiversity species, and they regulate climate change. However, there is human-induced land use and land cover change and deforestation that disrupts the proper functioning of such ecosystem services, especially in Ethiopia, forest lands are being converted to croplands because of the increasing demands of arable lands associated with high population growth, and even very steep and forested lands are being used for crop production, and this hampers the proper functioning of ecosystem services. So the objective of this study was to quantify the spatio-temporal trends of carbon sequestration and habitat quality in Ethiopia. Specifically, the study area is found in the northwest parts of the country along the Sudan border, and this area contains large forested areas in the past, however, and this due to its ecological abundance of forests. This region is considered as a green wall. As you see, in the south are the highlands, and because it prevents the expansion of deserts to south of the Ethiopian highlands, this area is considered as a green wall. However, due to high human pressure on natural resources, this area is degrading, and it hampers the proper functioning of ecosystems, and it affects the ecological connectivity. Data types and sources. For this study, I used different data from various of sources. The first data I used is Landsat 5 thematic mapper and enhancer thematic mapper plus, and this was obtained from the United States Geological Survey, and the other is Sentinel-2 satellite images from the European Space Agency. And we used other spatial data like population density, and it was obtained from the World Pop database, and spatial data like road networks and town maps from the Ethiopian Geospatial Institute, and these data were considered as a threat source for biodiversity degradation in the inverse habitat quality model. And the other is the carbon pulse data for each land use and land cover was adopted from the IPCC guidelines for national greenhouse gas inventories for different land uses. Since I didn't undertake direct measurements of carbon pulse, I instead used the IPCC guideline. The inverse model recommends the use of the IPCC guideline to to assign the carbon pulse for each land use and land cover. So I used the IPCC guidelines for national greenhouse gas inventories methodology to assign the respective carbon pulse for each land use and land cover. Data analysis to classify land use, land cover in different periods. I used the ERDAS imaging software especially for 1984, 2001, and 2022. And to predict the future likelihoods of the land use and land cover, I employed the combination of cellular automata, Markov chain, and the machine learning algorithms of multi-layer perceptual neural network just by using the Terset land change modeler software. And by assigning their carbon pulse data for each land use land cover, we tried to run the inverse carbon sequestration model, and we map the trends of carbon sequestration in the study area. And the same procedure for habitat quality, we assign the habitat suitability values for each land use and land cover, and by considering different trait data, we run the inverse habitat quality model and prepared maps that show the habitat quality of the study area. This is the carbon pulse data by land use, according to, and this is the habitat quality traits, his maximum distance, the trait weight, the respective decay functions. For this study, I use urban areas, rural towns, roads, and population density as a traits for habitat degradation, and the respective decay function and the trait weights. And the other is the land use, land cover, the respective habitat preferences. For instance, 1 indicates high habitat suitability and 0 indicates low habitat suitability according to the inverse habitat quality model. And the rest columns indicates their trait for degradation. And I consider, as I said before, croplands, urban areas, and towns and roads as a trait for habitat degradation for this study. The key finding is the study found that there is a decreasing trend of carbon storage value, especially in 1984, the total carbon storage value was 151 megatons. However, it decreased to 109 megatons in the next study periods of 2022. When we see as you see on the map, in the first study period, the carbon density was high. However, it decreased to the next study periods, as you have already seen from the map. When you see the carbon storage share by land use in the first study period, shrublands and forest lands share the highest proportion of carbon storage. However, their proportion decreased in the next study period because of their conversion to croplands. And this map shows the habitat quality of the study area in the first study period. The high habitat quality areas covered 44.8%. However, it decreased to 33.7% in the next study period of 2022. And it further, it is projected to be decreased in the next projection periods of 2014 and 2016 according to our projection. Conclusions, the study found that there is decreasing trades of valuable ecosystem services because of human-dominated activities in the area, and we recommend the carbon credits mechanisms and payment for ecosystems in order to increase the forest cover and to maintain the proper functioning of the natural ecosystems in the study area. Thanks for your attention. This is